Welcome to the Explainer. Ever wonder how your Node.js app can just handle a massive file upload without even breaking a sweat? Well, the secret is this super powerful, kind of low-level tool called Buffers. And today we're going to pull back the curtain and show you exactly how they work. So let's start with a basic truth. JavaScript, it loves text. It's a total pro with strings, JSON, you name it. But the real world, the modern internet, it runs on stuff that isn't text at all. Think about it. Images, video streams, network packets, that's all raw binary data. And when your nice, clean JavaScript code runs into that stuff, it kind of freaks out. It just hits a wall. And that right there is the exact problem Node.js buffers were built to solve. Yeah, and this slide really nails the whole issue, right? On one side, you've got JavaScript's world. It's all neat, tidy text. Think hello world or some clean JSON. But then you have the real world, which is full of image files, video streams, this messy binary stuff. You just can't treat them the same. It's like trying to read a photograph as if it were a novel. It's just not going to work. You'll get gibberish, corrupted data, and a very unhappy application. Okay, so here's what we're going to cover. We'll kick things off with a binary reality check, then introduce the hero of our story, the digital assembly line. We'll uncover its performance secrets, open up the Buffer Toolkit, see them in the wild, and finally, talk about the power and pitfalls. Let's get to it. First up, the binary reality check. So, let's really dig in here. Why can't we just use strings for everything? What makes them so terrible for handling raw data? Let's break it down. See, rather than trying to cram that square peg into a round hole, Node.js gives us this secret weapon. It's a specialized tool, buffers. And they are designed for one thing and one thing only, to take that chaotic mess of raw binary data and whip it into shape, giving it the structure we need to actually work with it. Okay, so we get the problem. Strings are out for binary data. So now let's meet the solution head on. Section 2, the digital assembly line. Let's introduce the star of the show, the Node.js buffer. This is where it all starts to click. So what is a buffer? Well, the best way to think about it is like a digital assembly line. It's a chunk of memory with a fixed size. And here's the key part. It lives outside the normal JavaScript world. It's just holding raw, pure bytes. No interpretation, no funny business. Just the raw materials ready for you to start building. And creating one is super straightforward. When you write something like const buffer equals buffer.alloc10, what you're really doing is telling Node, hey, set up a brand new assembly line for me. Make it exactly 10 bytes long and make sure it's clean. And Node does just that. It gives you a buffer filled with zeros, totally empty and ready for whatever data you want to throw on it. All right, moving on. Section 3, the performance secret. Now, this is really the core of why buffers are so critical to Node.js. I mean, it's not just that they can handle binary data, it's that they do it with mind-blowing speed and efficiency. And that's the whole point of Node, right? The difference is just night and day. If you try to use strings, your code is constantly struggling. It's encoding, decoding, converting binary into text and back again. It's slow, it eats up a ton of memory. But the buffer approach, it's like a hot knife through butter. It works directly with the computer's memory. It skips all that wasteful conversion overhead. It's just fast. And the result? Well, you can see for yourself. It's no contest. For these kinds of binary jobs, using buffers isn't just a little bit faster. We're talking orders of magnitude faster. Sometimes 10, sometimes 100 times faster. For any app where performance matters, this is a total no-brainer. Okay, so we'd established the why. You get it. Buffers are fast and necessary. Now for the how. Let's pop open the hood and check out your Buffer Toolkit. Time to get practical. You've got 3 main ways to create a buffer. Alloc is like your clean slate. It's safe, reliable, and gives you a fresh, zero-filled buffer every time. Then there's allocUnsafe, the recycler. It's faster for sure because it just grabs a piece of memory without cleaning it first. But buyer beware, it might have old data scraps lying around. And finally, you have buffer.from, the transformer. This is what you use when you already have data, like a string or an array, and you need to turn it into a buffer. So once you have your buffer, your assembly line, what can you do with it? Well, you can write data to it in all sorts of ways. You can write simple text like hello. You can poke a specific byte value directly into a slot, or you can even write very specific number types. And reading is just the reverse. You can tell it to interpret the bytes as a string, spit out the raw hex code for debugging, or read back that specific number you wrote earlier. It's super flexible. Okay, that's the theory, but where do you actually see this stuff? Let's look at a perfect real-world example, handling a file upload. This is where buffers are not just nice to have, they are absolutely essential. So here's the typical workflow. Step 1, collect. As the file streams into your server, you're not getting it all at once. You're getting it in little pieces, or chunk buffers. So you gather all those up. Step 2, combine. You take all those little chunks and you use buffer.concat to stitch them together into one big, complete buffer that represents the whole file. Step 3, validate. This is a cool security trick. You can peek at the first few bytes of the file's signature, to make sure it's actually a PNG or whatever you're expecting. And finally, step 4, save. You take that final, complete buffer and write it straight to the disk. Done. It's clean, super efficient, and way more secure. All right, section 6. With great power comes great responsibility, right? Buffers give you a direct line to your computer's memory, which is amazing, but you gotta be careful. So let's talk about the power and the pitfalls, how to use these things wisely. Honestly, the main rule is pretty simple. If you're dealing with data meant for a machine, think files, network protocols, cryptography, use a buffer. If you're dealing with data meant for a human to read, like JSON, HTML, or user input from a form, use a string. It's all about picking the right tool for the right job. And here are a few key pitfalls to watch out for. First, memory leaks. Buffers can be big, so don't just let them hang around in memory if you don't need them anymore. Second, that allocUnsafe we talked about, be so careful with it. If you don't fill that buffer completely, you could accidentally leak old, potentially sensitive data that was in that memory slot before. And last, just be aware that buffers aren't infinitely large. There's a max size, usually around 2 gigabytes, depending on your system. And here's a really cool modern update. In the old days, buffers were kind of the special Node.js thing. Not anymore. Today, Node.js buffers are actually just a type of UNT array, which is a standard part of JavaScript itself. So what does that mean for you? It means they play nicely with all sorts of modern web APIs, like WebAssembly. This makes them more integrated and way more powerful than they've ever been. So when you boil it all down, what are buffers? They're the bridge. They connect the friendly, high-level world of JavaScript that we love with the raw, powerful, low-level binary world of the computer. If you want to write truly high-performance code in Node.js, you have to understand them. Master buffers, and you really do master the language of computers.